Hi, this is Nagaraj. Today I'm going to show you something very interesting. So this is called GAN. GAN is Generative Adversarial Network. So what does the GAN do? GAN takes the real images, thousands of real images, and produces fake images that you can't distinguish between the real and the fake images. Let me show you some example of GAN. Okay, so here on the left side you see these are real images, and on the right side these are not the real images, although they look like the real people, but these are the images that are generated by the network. Okay, so let me go a bit into the architecture of how the GAN works. Okay, so where is my image? Okay, it's here. So GAN, Generative Adversarial Network, has two components. One is discriminator and generator. So note that both are neural networks. Discriminator is a neural network. It may have some 5 layers or 10 layers of linear and convolutional network combinations, and this may also be like 10-layer network or 5-layer network. That we will go into it later. Okay, so what is the job of the discriminator? Discriminator, what it does is it learns to discriminate between the real and the fake images. So let's say I have 1000 real images here and I feed it to the discriminator. Okay, it learns the weight of the images so as to discriminate between real and fake. So for real images it produces a 1. Okay, and for generated images it produces a 0. Okay, and it updates the weights continuously over this 1000 images so as to learn to discriminate. Okay, what does a generator do? Okay, generator is a random network. Okay, it's very interesting theory. Okay, so what we do is we just feed some random numbers, maybe let's say 100 random numbers or 1000 random numbers to generator. It has a neural network. It may have like 5 layers or 10 layers. What it does is, using the neural network, it produces the numbers which is similar to the shape of the image. Let's say your image is 3 cross 64 by 64. So generated images will be 3 cross 64 by 64. Okay, so these when they are fed to the discriminator is supposed to classify them rightly as the fake images. That is a 0 for the fake images, 1 for the real images. Okay, but when this is discriminated or correctly classified as fake, okay, but my loss function for the generator, okay, compares this against the real image. That means even though I get 0, it says, the loss function says the ground truth should have been 1, but the ground truth is 0 because it's a fake image. But my loss function compares this 0 against the ground truth 1. Okay, that means it fakes the generator. So loss function wants a 1, but the output of discriminator is 0. So every time this generator gets trained, every time the weights get updated, and every time it sees a 0, again it updates the weights of generator. This keeps happening till generator starts actually outputting something which discriminator detects it as a 1. That means the random numbers that are generated here and fed to generator, and it's producing a set of numbers which is equal to the shape of the image, that becomes real. And how does the image look? We don't know, but it will look like a real image because it's getting discriminated correctly. Okay, this is very interesting theory. We'll go into the implementation and you won't believe it. This really works. Okay, thank you. Let's go into the implementation next.